Welcome students. We are back with another lesson. In this lesson, we'll discuss numerical on power of lens. Now before we solve some numerical, let us revise our power of lens. The power of lens equals to 1 upon f, where f is the focal length of the given lens. Fine. Apart from this one, if we want to write power of lens in terms of your refractive index and your radius of curvature, I can write power of lens equals to mu minus 1 upon r1 minus 1 upon r2. Now this formula is applicable for your convex as well as your concave lens. Fine. Both of these lenses will follow the same formula. Apart from this one, what is the SI unit of power? The SI unit of power is diopter, which is represented by capital D. Fine. Fine. So using this concept, let us solve our first question. Now the question is given as follows. The radius of curvature of each surface of a convex lens of refractive index 1.5 is 40 centimeter. Calculate its power. So in the question they have asked you to find the power of the lens. Fine. You have to find the power of the lens. Now let us look what are the hints given in the question. The first hint they have given is that what kind of lens is this one? It is a convex lens. Now what is the refractive index given? The refractive index is 1.5. Apart from refractive index, what is the radius of curvature? The radius of curvature is 40 centimeter. Fine. So if we want to take a visual help, then okay, suppose you have a convex lens, okay, like this one. This convex lens has a principal axis which passes through the center. Fine. Now this is the first refracting surface of your convex lens. Fine. For this first refracting surface, let us consider this point as your center of curvature, C1. Fine. Now this is your second refracting surface. For the second surface, let us consider this point as your center of curvature, C2. Fine. Now for your first refracting surface, the distance from the center of the lens to C1 is your radius of curvature. Fine, which is denoted by R1. Now again, for the lens, from the center of the lens to the center of curvature for your second surface, this distance is your radius of curvature for your second refracting surface, which is denoted by R2. Fine. Now for your first refracting surface, R1 is positive. This is positive because it is in the direction of the incident light. Fine. It is measured in the direction of the incident light. Whereas R2 is measured in the direction opposite to the incident light. Hence your R2 should be negative. Fine. So let us write these details here. So we'll write down solution. Okay. Here. Okay, first what they have given? The refractive index. How much is the refractive index of this convex glass lens? It is 1.5. So I can write down your refractive index mu equals to 1.5. Okay. Now apart from this one, what is the radius of curvature? 40 in terms of magnitude. Okay. So let us write down R equals to plus 40. Fine. Now this is given in centimeter. And why it is plus? Since it is measured in the direction of the incident line. Fine. This is your R1. Next, R2. R2 is also 40 centimeter. Fine. But will it be positive or negative? It will be negative. Okay. Fine. So these are the details given in the question. Now, here we have to calculate the power of lens. Okay. Your power of lens. Okay. I'll just write. What is the SI unit for power? SI unit for power equals to diopter, isn't it? Just now we have discussed. Now diopter in turns equals to 1 by meter. Fine. It is 1 by meter. So what we are dealing? We are dealing with a MKS system. Okay. But your details, your hints are given in CGS system. So in order to calculate the power, you have to convert the CGS to MKS system. Yeah. Can you see this is given in centimeter? You have to convert it into meter in order to avoid any mistakes. Yeah. So how much is, so to convert centimeter to meter, 100 centimeter equals to 1 meter. Fine. And 1 centimeter will be equals to how much? What we'll do take this 100 to the other side, so it will be 1 upon 1 by 100 meter. Fine. Okay, so I'll just keep it in a box. Fine. Now let me just take it to the other side. Okay, let me take this one also, keep it somewhere here. Fine. Okay, so now what we have to do, we have to convert this centimeter to meter. 1 centimeter equals to how much? 1 by 100 meter. So how much is 40 centimeter? So using this relation, your 40 centimeter equals to how much? It will be 40 by 100 meter. Fine. This 0 gets cancelled. 4 divided by 10 equals to 0.4 meter. Fine. So how much is 40 centimeter equals to 0.4 meter? So let me write down here, equals to plus 0.4 meter. Similarly, R2 equals to minus 0.4 meter. Fine. Now we know how is the power of lens given. Power of lens in terms of your refractive index and radius of curvature. Your power of lens can be written as P equals to mu minus 1 by R1 minus 1 upon R2. Fine. Now let us substitute the values here. How much is mu? Mu equals to 1.5. Fine. How much is R1? R1 equals to 0.4 meter. Minus how much is R2? R2 is minus 0.4 meter. Fine. Now, how much is 1.5 minus 1? 1.5 minus 1 is 0.5. Fine. Now, your 0.5 can also be written as 1 by 2. So, instead of writing 0.5, I'll write down 1 upon 2. Fine. Now, look here. What happens? This negative and this negative will become positive. So therefore inside the bracket I'll have 1 upon 0.4, minus and minus will become plus 1 upon 0.4. Fine. Now again, what is 1 upon 0.4 plus 1 upon 0.4? It is equals to 2 upon 0.4. Fine. So I can open this bracket. If I open this bracket, if I open this bracket, this 2, this 2 and this 2 can get cancelled. So I'll just cancel them out. Fine. So what I'm left with, your power of lens equals to 1 upon 0.4. Fine. Okay. So how much is 1 upon 0.4? If you calculate using your calculator, it comes around somewhere 2.5. Fine. And what is the SI unit for power? SI unit for power is diopter. So the power of the given convex lens is how much? 2.5 diopter. Fine. So it's a simple question. Fine. So you should not have any doubt in this part. Now let's move on to our next question. Okay. Now our next question has three parts. So let's read the question first. If the focal length is 0.5 meter for a glass lens, what is the power of lens? This is the first part. Now the second part, the radii of curvature of the faces of a double convex lens are 10 centimeter and 15 centimeter. Its focal length is 12 centimeter. What is the refractive index of glass? Fine. And the third part of the question, a convex lens has 20 centimeter focal length in air. What is the focal length in water? and the hints they have given is refractive index of air to water is 1.33, refractive index of air to glass is 1.5. Okay, so let's solve our first question. Now in your first question, what they have asked you to calculate, they have asked you to calculate your power of lens. Okay, apart from this one, what they have given, they have given the focal length. Fine. Now, so to start with, let's write down solution for first part. Here, focal length is how much? They have given us 0.5 meter. Okay, and you know, power of lens equals to 1 upon f. Now I've already said this power of lens, okay, it is same for convex as well as concave lens. It doesn't depends upon the type of the lens. Therefore, I can use the same formula. Okay, now in this case, how much is the focal length? 0.5. So I'll write down 1 upon 0.5. Fine. 1 upon 0.5 equals to 2. And what is the sign? Positive. What is the SI unit? Diopter. So what is the power of the given convex lens? It is 2 diopter. Fine. So this is the first part. Okay. Coming to our second part, the radii of curvature of faces of a double convex lens are 10 centimeter and 15 centimeter. Its focal length is 12 centimeter. What is the refractive index of the glass? Fine. Okay. So I'll write down for part 2. Okay. Now, what they have asked you to calculate the refractive index, of the glass surface. Fine. Now, what are the hints given in the question? The first hint is given is that what kind of lens it is? It is a double convex lens. Fine. Apart from this one, they have given the radius of curvature. Fine. For the first refracting surface, it is 10 centimeter. For your second refracting surface, it is 15 centimeter. Fine. Now the next thing they have given is your focal length. Focal length is how much? 12 centimeter. Fine. So to take the visual help, I'll just draw the rough diagram. Consider you are given a convex lens. Okay, this is your convex lens and this is your principal axis. Now, for your first refracting surface, okay, for your first refracting surface, this point, let us suppose this is C1, then this is R1. Fine. Next, they have given if this point is C2, this point, this distance will be R2. Fine. Okay, so next they have given if this point, let us consider this is the point where the light intersects after refraction. This point is your principal focus. Then this distance is your focal length. Fine. And they have asked you to calculate its refractive index. Okay. Let me just move this diagram a little bit to the other side. Okay. Now look here. They have given you the radius of curvatures R1 and R2. Fine. So according to the question, here R1. Okay, R1 they have given how much? It is 10 centimeter. So it should be plus 10 centimeter. Okay. The first radius of curvature is positive. Fine, since it is in the direction of the incident line. Next, how much is your R2? R2 they have given in the question around 15 centimeter. But since it is measured in the opposite direction, so it will be minus 15 centimeter. Fine. Apart from this one, they have given the focal length. Focal length is how much? 12 centimeter. Since it is a converging lens, so it is should be a plus 12 centimeter. Fine. So these are the hints given in the question. Okay. Now you know power of lens P equals to 1 upon F. Okay. But since they have given the radius of curvature, so I can also write the power of lens equals to mu minus 1 upon R1 minus 1 upon R2. Right. Okay. So there's one note. Okay. Just I'll write it somewhere here. Note. Power of lens equals to mu minus 1 1 upon R1 minus 1 upon R2. Fine. Where this mu is the refractive index of glass. Fine. Okay. So this formula is applicable when this formula will be applicable when they have not given anything about the surrounding medium. Okay, they have not mentioned about the surrounding medium. If refractive index, Ri means your refractive index of surrounding medium medium is not given. Okay, like in this case, have they mentioned anything about the surrounding medium throughout the question? No. If they have not mentioned about the surrounding medium, then I can use this relation. Apart from this one, if they have mentioned that your surrounding medium is air, surrounding medium, okay, let me just take it a little bit up. That the surrounding medium is air, then also I can use this formula. Fine. Note, if they have given the surrounding medium, okay, the refractive index of the surrounding medium, in that case you cannot use this formula. Okay, you have to use this formula. Fine, you have to first find out the focal length and then you have to calculate the power. Okay, this type of problem we'll see in your part 3. Fine, for now just remember this formula is applicable when they have not given anything about the surrounding medium and if the surrounding medium is air. Okay, so I'll just keep this inside box. Fine, fine. So now look here, this is power, this is power. The left hand side are equal, therefore the right hand side should also be equal. Hence I can write 1 upon F equals to mu minus 1. Okay, since this is a glass lens, okay, so I'll put a G here. Similarly here I'll put a G. So mu minus mu G minus 1 upon R1 minus 1 upon R2. Right? So from here we can find out your focal length. So what is the refractive index of the glass? Mu G. Okay, they have not given refractive. We have to calculate mu G. Fine. So what is the focal length? Focal length is plus 12 centimeter. Okay. So I'll write down, yeah, 1 upon 12. Now, if we are dealing with centimeter, make sure all of the units are in centimeter. Fine. Now, what is mu G will remain mu G. We have to find mu G. Okay. Minus 1. How much is R1? R1 is plus 10 centimeter. How much is R2? R2 is minus 15 centimeter. Fine. Now here minus and minus will become plus. Fine. Now for this part inside the bracket I can use the LCM method. Okay, So the lowest common multiple of 10 and 15 is 60. So yeah, if I'll take the LCM, then I will write 60. Okay. So 10 6 is 60 plus 15 4 is 60. Fine. Now 6 plus 4 equals to 10. So instead of writing 6 plus 4, I'll write down 10. Fine. And 10 by 60 equals to 1 upon 6. So I'll write down 1 upon 6 here. Fine. Now look, this 6 can go here. Cross multiplication. I'll send this 6. Yeah. Fine. If 1 goes here, doesn't matter. Okay. This is cross multiplication. 6 goes to the numerator, 1 goes to the denominator. Fine. So let me send 6 there. So here I'll write down 6. Fine. Now I can cancel 6 ones are 6, 6 twos are 12. So yeah, 6 ones are 6, 6 twos are 12. So what I'm left with? 1 by 2. Fine. Or I can write mu g minus 1 equals to 1 upon 2. Okay. Now 1 upon 2 you know is how much? 0.5. So instead of writing 1 upon 2, I'll write down 0.5. Fine. Now, if I take this minus 1 to the other side, then minus will become plus. So 0.5 plus 1 is how much? 1.5. Fine. So I can write down equals to 1.5. Therefore, the refractive index of the given convex lens which is made of glass is how much? 1.5. Okay. Anyway, the refractive index of glass is always 1.5. Fine. So we can verify from here also. Fine. Okay. Now coming to our third part of the question. Okay. Now coming for the third part of the question. Now we will see the importance of this note. Okay. Okay. Now let's read the question. A convex lens has a focal length 20 centimeter in air. Okay. What is the focal length in water? Refractive index of air to water is 1.33. Refractive index of air to glass is 1.5. Fine. So in this question, they have asked to calculate the focal length of the water. And what they have given? They have given what kind of lens you have? Convex lens. What is the focal length of this convex lens in air? 20 centimeter when the surrounding medium is air. Fine. Apart from this, they have given the refractive index of air to water is how much? 1.33. And the refractive index of air to glass is how much? 1.5. Okay. So let me write down solution. Here, what is the focal length of the convex lens in air? Okay, the focal length in air. Okay, I'll denote it with FA. This A denotes your air. Fine. It is how much? Plus 20 centimeter. Fine. Next, what is the refractive index of for air to glass? Air to glass. That means if a light propagates from air and it enters the glass, how much is the refractive index? 1.5. So I'll write mu. It travels from air to glass. Fine. Now look here. As I've already stated, that this refractive index can be written as the refractive index of glass mu of G upon mu of air. Fine. And how much is the refractive index of air? Refractive index of air is 1. So I'll write mu G upon 1. Fine. Which in turn equals to mu G. Fine. So the refractive index of air to glass is same as refractive index of glass. Fine. So instead of writing air to glass every time, I can simply write refractive index of the glass G. Fine. So refractive index of air to glass or refractive index of glass should be equals to how much? 1.5. Okay, which we have calculated in our previous problem also just now. Right. Apart from this one, refractive index of air to water. Fine. This can also be written as simply refractive index of water. Okay, you can follow the similar steps. Then again, you'll get refractive index of water. So instead of writing everything, I can simply write down. So refractive index of the water is given. How much? It is equals to 1.33. Fine. Okay. So now, first what we will do, we will consider our, let us say this convex lens. Fine. Consider your convex lens placed in air. Okay. So yeah, let me just wait a minute. Right now, consider your glass convex lens of refractive index mu g is placed in air of refractive index mu a. And how much is refractive index of air? The refractive index of air is always equals to 1. Fine, I'll just write down here. Okay, and how much is the refractive index of this glass surface? It is 1.5. Fine. Now, if it if your surrounding medium is air, okay, if the surrounding medium is air, then I can use this formula. Wait, first let me write down for the lens placed in air. Fine. For the lens placed in air, I can use this formula 1 upon f equals to refractive index of glass minus 1 upon R1 minus 1 upon R2. Fine. This is the refractive index when it is placed in, this is the, sorry, focal length when it is placed in air. Fine. Now look here. This is the focal length of this convex lens. Mu g is the refractive index of this convex lens. Apart from this one, R1 and R2 are the radius of curvature of this convex lens. Now here you know the focal length of this convex lens when it is placed in air, which is around how much? 20 centimeter. You know the refractive index of this glass surface when it is placed in air. It is how much? 1.5. Fine. Now from here we'll find out this bracket part. Fine. 1 by R1 and minus 1 by R2. Okay, let's find out this value first, then I'll tell you why we'll find out this value first. Okay, so now in the question they have given FA equals to 1 upon 20. Your refractive index of glass is 1.5, then minus 1, and then 1 upon R1 minus 1 upon R2. Fine. Now this 1 upon 20, let's keep it like this only, 1 upon 20 equals to, how much is 1.5 minus 1? It is 0.5. Instead of writing 0.5, for simpler calculation, I can write as 1 upon 2. Right. In this part, I'll keep the same 1 by R1 minus 1 upon R2. Now, 1 by 2, if it cancels 1 by 20, then this will give me how much? This should give me 1 by 10, or you can do also like this. Send this 2 to the numerator, 1 to the denominator, cross multiplication. Okay, so write down 2 here, cross multiplication. Fine. Now here this 2 ones are 2 and 2 tens are 20. Fine. So I can write down from here 1 upon R1 minus 1 upon R2 equals to 1 by 10 centimeter. Okay, fine. Okay, let's give this equation some number. I'll give this one as equation 1. Fine. Fine. Now what I will do, I will take this glass surface and I'll put it inside the water. Now listen very carefully. Let me make this little bit bigger, okay? Okay, if you can see now clearly. Fine. Now what I've taken this glass surface and put it inside the water. Now here, what is the refractive index of the water given in the question? 1.33. Fine. And what is the refractive index of this glass surface? It is 1.5. Fine. So the refractive index of water is 1.33 and the refractive index of this glass surface is 1.5. Fine. So we'll consider our next case for the lens placed in water. Fine. Now look here. This glass surface has radius of curvature. Fine. And the difference of this inverse of radius of curvature 1 by r1 minus 1 by r2 is given how much? 1 by 10. Now listen very carefully. This difference of this radius of curvature will not change when I place it from one medium to another. Why? Because your radius of curvature does not depend upon the medium. Therefore, I have calculated this value. Okay, fine. This R1 and R2 is independent of the medium. So using this, I can calculate the focal length of the water. Fine. So now, in this case, the surrounding medium is water, but in this case, the surrounding medium is air. So what did I say? Can we use this formula? No. So we have to make a slight modification in this case. Okay. So in our case, I'll write down 1 upon focal length of water equals to the refractive index of glass upon refractive index of what wait just a minute water minus 1, fine, equals to 1 upon r1 minus 1 upon r2. Okay, now why did I have written this one glass to water? Because look carefully, your light is traveling from water first and then it will enter the glass. Fine. The light travels into the water. It travels from water and then it enters the glass. So if I have to write down in terms of refractive index, this will be written as okay. So mu, it travels from water to glass. This will be written as the refractive index of glass upon the refractive index of water. Fine. Using this formula. Fine. Fine. Let me put this in a box. Okay. Fine. So now What is the refractive index of the glass given in the question? It is 1.5. What is the refractive index of the water? 1.3 minus 1. And how much is 1 by R1 and R2 from equation number 1? It is equals to 1 upon 10. Fine. Now, okay. So 1.55 divided by 1.33 is, you can use your calculator for this calculation. Okay. So 1.5 divided by 1.33 is, I can write down, it is equals to 1.1278. Fine. And 1.1278 minus 1 equals to 0.1278. Fine. Now, if you divide this number by 10, okay, so I'll get 0.0.1278. Fine. So 1 by FW. Okay. Now what you can do, either take this FW in the numerator, then this one will go to the denominator, or what you can do is cross multiply. Send this FW to the numerator and 0.01278 to the denominator. Fine. So if I send this one here, then my focal length FW equals to, okay, for this calculation, okay, you can use your calculator, 78.2. Fine. And in which unit you are measuring? Centimeter. Therefore, the SI unit for focal length should be 78.2 centimeter. Fine. So can you see what you have noticed? The focal length of this glass in air is how much? 20 centimeter. But if you place it in the water, what happens? The focal length in the water becomes 78.2 centimeter. In that case, what happens? Suppose your light, okay, consider a light which falls on this surface. After diffraction, it will pass through the principal axis. And suppose this line is your principal axis. Okay, in this case, for the first case, okay, so for the first case, the light will intersect the principal at what distance? It will intersect at 20 centimeter. Fine, this distance should be 20 centimeter. But in your second case, what happens? If the light falls, in that case, first let me draw a principal axis. Fine. Suppose you have a light which strikes on the in your lens. After refraction, it will pass. Fine. After a distance, it will cross the principal axis somewhere at this distance. Fine. Now what you have noticed is that the point of intersection has increased. Can you see? It has increased almost 3 times of the previous case. Okay, this is 78, or more than 3 times of the previous case. Fine. So this equation tells the importance, okay, that you cannot use the same formula, this mu g mu minus 1, when the surrounding medium is air. You cannot use this same formula for your water. Fine. If there is a water, you have to make sure of this condition. Okay. Be careful with this condition. Fine. Okay. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So again, thank you.